In this video, we'll use an example to show how to do file I/O and exception handling in C#. The example we'll develop is an English to Spanish translator. The program will use the English-Spanish dictionary file provided by the Internet Dictionary Project. The project seems no longer exists, so I'm hosting this file on my own server. Now let's download the file and have a look. So this is what the dictionary file looks like. First, notice that the file contains some comment lines. Each comment line starts with a pound sign. Each regular line starts with an English word and then a tab character. Notice that it's a tab character, not a space. And then the Spanish translation. Another important thing to notice is that an English word may have multiple Spanish translations. For example, the word artback has two Spanish translations. So given this file, we want to write a program that first reads the file into an in-memory data structure for easy lookup. Specifically, we'll use a dictionary in C#. The key of the dictionary is the English word, and the value is the Spanish translations. Because one word can have multiple translations, the value is actually a list of string rather than just a string. Once we read the file and construct the dictionary, we can ask a user to enter an English word from console input and display the translations to the console output. The first thing we need to do is to read the file. There are two ways to do it. The easier way is to use the utility methods in the C# file class to read the whole file. Let's see the example in the documentation. As we can see here, we can read a whole file into one big string using read all text. And we can also read a file into an array of strings, one line per string, using read all lines. This is more suitable for our example as we'll need to process each individual line. Reading the whole file into memory is convenient in most cases, but sometimes the file is too large to fit into the memory all at once. In those cases, we can read in one line at a time using Stream Reader. Let's see an example. So here, if you remember using buffered reader in Java, you'll see that it's pretty much the same thing as in Java. We create a stream reader, we read in one line at a time, and then we close the reader. Now, let's look at another example for stream reader. This is another example using stream reader. It's quite similar to the last one with some additional exception handling, which we'll talk about later. If we only look at these few lines, we notice an important difference comparing to the previous example. Here we say using stream reader and we don't close the stream reader when we are done using it. But in the previous example, there's no using, and we need to close the reader afterwards. So what exactly does using mean? We already know that using is used to import a namespace in C#. It also has a second usage. It's used also to automatically dispose objects that implement the iDisposable interface. As you can kind of tell from the name, iDisposable is an interface implemented by objects that need to be disposed after use. Now, if we expand it here, we can see that there are many such objects. Most notably, file handlers, database connections, and so on need to be disposed in order to release the resources they hold. There are two ways to use using in C#. One is what we saw in the screen reader example. We say using, then parentheses, and we create a disposable object inside the parentheses. The parentheses is followed by a code block inside braces, and at the end of the code block, the object is disposed. And very importantly, it will be disposed even if there's an exception. C#8 introduces another syntax for using. We could just use using in front of a regular variable definition. This way, we don't have to introduce an additional code block and indentation, and the object will be disposed at the end of the current code block, which is usually the end of the method. Just a little bit more about system I/O before we actually do the translator example. As we can see here, for the most part, it's like the Java I/O package in Java, where we can find all kinds of classes and interfaces for I/O operations. One common confusion for Java programs learning C# is the file class. In Java, a file object represents a file or directory, and we can use it to check if the file exists. We can use it to rename the file, delete the file, and so on. If we look at the file class in C#, we can see that it's first of all a static class, and secondly, of course, inside the static class, there are only static methods. It provides a bunch of static methods we can use, like the read_all_lines method and the read_all_text method and so on, but we cannot create a file object from it. It turns out that the directory info and the file info classes are the equivalent of the file class in Java, while the file class and the directory class provide static utility methods like read_all_lines. And by the way, in Java, both files and directories are represented by the same file class, but C# splits it into file info and directory info. Okay, now with that, let's actually write the translator program. So the dictionary file is under this folder, so it should be under the C drive, users, CY_Song, and downloads folder. and the name of the file is Spanish with capital S dot txt. So then let's first create the class. We'll say class translator, and this class should have a dictionary. As we mentioned earlier, the first thing we want to do is we want to read the file and store the translations into a C# dictionary with English word as a key and Spanish translations as a value. So I'll make this a private dictionary with string and a list of string, and we'll call it dictionary. The reason I make it private is because I don't want people to use it directly. We'll provide a method that people can use. We'll import the collections.generic namespace, and dictionary. Okay, sorry, I misspelled it. Okay, so now it's good. And then we'll have a constructor, and this constructor will be responsible for reading the file. We'll do public translator, and we'll take a string, which is the path to the file, and then we'll do file read all lines. I think that's the method. Let's import file, and okay, so this one is as we can see here, it's an array of strings. So this should give us all the lines. And then we need to go through each line. So we'll do each line in lines, and then we'll need to do something. Oh, before we do anything, we need to create the dictionary first. So we'll say dictionary is new dictionary. Okay, good. Now remember, the file looks like this, and it has some comment lines, and we want to skip those comment lines. And that should be easy to do. We'll say if line starts with this, we'll do continue, so that should skip it. And if not, if it's a regular line, then we need to split this line into the English word and the Spanish translation, and we'll do words is line dot split. So split has many different forms. The first one actually looks promising. It says we can specify a number of separators as a character array. Notice that there's a parameter modifier here, meaning that instead of specifying it as an array, we can actually specify it as one by one individually. Okay, so that's wonderful. And we know the tab character is the separator, and so we'll use that to split the line. Now, words should, after split, words should be an array that has two elements. The first one is the English word, and then the second one is the Spanish translation. Okay, so now we need to decide whether the English words is already in the dictionary or not. And if not, we need to create a new entry. If it's already in there, we should add the translation to the existing entry. So it will be something like this. If dictionary contains key word 0, This means the dictionary already contains the English word, and then we can simply add it to the value part or the list in the dictionary. Now, how do we get the value part given a key? And this is something worth looking at in the documentation. Let's go find dictionary, this one. So in Java, if we use a map, then to get a value based on a key, we can just use get and specify the key. However, if you look at the methods in dictionary, you won't find a method that's equivalent to the map get method in Java. The reason for that is dictionary actually uses if you remember, this is something we talked about in the collection lecture, something called an indexer. So it uses an indexer which has a parameter, and the key can be used as a parameter, and it will return the value given the key. So the code will look something like this. It will be dictionary, the indexer, and we'll give it the key, and it returns the value part, and we can then add the Spanish translation into the value part. Now this is if the English word is already in the dictionary. What if it's not in the dictionary? Well, then we'll need to create a new list. We'll call it translations, and it will be a new list of strings, and we'll need to add the translation to it, and then we'll need to add the key, which is the English word, and the translations into the dictionary. Okay, so if everything goes well, then after this, the dictionary should be populated, and that's great. So now we are done with the constructor part. Of course, we also need to provide a way to look up the dictionary. So we'll create a method, and this one will return the translations, and we'll call the method translate, and it will take English word. Again, we will need to check if the word is in the dictionary or not, and if it's not, I want to return an empty list instead of a null list, because a null may cause a null pointer exception. An empty list at least will be something already in there. Okay, so what do we do? Okay, so we can do something like this. We'll say return dictionary contains keyword. If it does, we will return dictionary word, so the value part. Otherwise, we'll return empty list, something like this. Okay, so we'll see if it works or not. Okay, so now we have our translator class, and then here we can create a translator class, translator object. We'll say new translator, and then we need to give it the path of the file, and it should be it should be users, CY_SUN, downloads, and Spanish.txt, something like that. We mentioned before that this I cannot remember this is a backwards or the forward slash. In any case, this slash is the escape character in C# and in Java. It has a special meaning. Now, if we want to use it verbatim, we would need the verbatim identifier like this. And this is also typically what you see in .NET documentation. Another way to do this is simply use the other slash, which is actually better because the other slash works not only on Windows but also on other platforms. So in this case, you don't need the verbatim identifier anymore. So we'll get our translator, and then we'll say, please enter an English word. We'll use write so the user can enter it on the same line, and then we'll do word is console read line, and then we'll say translations is translator translate, something like this. And then we'll need to print out the result. We'll say the translations are translations will we'll add a type character, and then we'll do the translation. And make it interpolated string, something like this. So, well, let's try it and see if it works. Okay, so we're not seeing an exception. That's a good sign. At least it found the file. And enter an English word. We'll say hello. It shows hola and Qtao. I'm not, I don't know Spanish, so I'm not sure whether it's correct or not. But let's try aardvark. I cannot copy and paste. So aardvark. Okay, so it does seem to be correct. Okay, so this is the translator example. I hope to use this example to show not only the file input, but also as an example for using collection classes, in particular the two most commonly used ones, list and the dictionary. Okay, so now that our program works, let's add a little exception handling to it. One common problem with programs that deals with files is the file not found error. Let's say that we want to catch that error and exit the program gracefully. The code related to exception handling in C# is mostly the same as in Java. If we want to throw an exception, we say throw new and creating an exception object. If we want to catch an exception, we do try catch and finally. Note that any code in the finally block block will always get executed regardless of whether an exception happened or not. One big difference between Java and C# exception is that many exceptions in Java are the so-called checked exceptions, meaning that we have to either declare them or catch them in our code, and this can get a little annoying at times. C#, on the other hand, does not have checked exceptions. In our code, for example, if we don't care about the file not found exception, we don't have to do anything about it. With that said, let's do at the exception handling part. If we look at the program, we can see that we can catch the exception here when we read the file, or we can catch the exception in the main method. Now, which one is better? In my opinion, it depends on the situation, and here it's better to do it in the main method, because if we cannot find the file, there's really nothing else we can do. We might as well just exit the program. So there's no need to catch it here and then return like an empty translator, and then we wouldn't even know if something bad happened. So might as well just try catch it here. If something bad happens, we just exit the program. And this, by the way, is kind of the spirit of exception handling. It's basically give you the freedom to handle it in places where it makes sense, not just handle it right at the part where the problem happened. Okay, so what we'll do is we'll do a try catch like what we would do in Java, and the syntax is exactly the same. Even the exception name, I think, is the same. It's also called file not found exception, and then we say cannot find file dictionary file, something like that. And so if exception happens, it will get into the catch block, and then there's nothing afterwards, so the program will end. And let's say we type the file name wrong. Instead of Spanish, we miss the H at the end, something like that. If we run it, we'll get an error that says cannot find. Well, it's not an error. We get an output says cannot find dictionary file. And that's it. We don't get an exception or unhandled exception, and that's good. So again, it's mostly the same as in Java, but let's talk a little bit more about the exception class itself. As usual, let's take a quick look at the documentation. So this is the exception class, and we can see that it has a few properties and a few methods. The important ones are here. Message is these are all properties, by the way. The message property is, of course, the string message associated with the exception. And the stack trace, of course, is the stack trace like in Java. Target site sounds like something related to a website, but actually is something we can use to get a method that throws the exception. The data property holds additional data associated with the exception if there is any, and these data are in the form of key-value pairs. The C# language already defines a bunch of exceptions. Please take a look at the documentation. Here are the standard exceptions already defined in C#, you should have a look and just get a general idea of what's already defined, so that you don't create a custom exception when there's already something that does the job in the standard library itself. For example, if you write a method that accepts certain kind of argument, and if a user doesn't pass the right argument, you can throw an argument exception instead of creating some custom exception yourself. Now, with that being said, sometimes you do want to create a custom exception, and here are the minimum requirements for a custom exception. First of all, it has to inherit from either the exception class or the application exception class. Then it must have at least two constructors. One takes no argument and one takes a string argument. It's kind of hard to remember this, but fortunately, there's an exception code snippet we can use. So, for example, if we want to do a custom exception class, just type exception in Visual Studio and press the tab key twice, and this will expand the snippet into a skeleton of a custom exception class. Then we can modify it as necessary. So, okay, this is it for this video. File I/O is covered in Chapter 20 of the Pro C# Notebook, and exception handling is in Chapter 7. Please check it out. Thanks, and see you in the next video.